Welcome to everyone, and thank you for coming along to this presentation. It's a presentation on the multi-product consumer test evaluation package that's been developed over the past 5 to 6 years. It's a series of JSL scripts assembled into an add-in and runs obviously with all the access to JMP functionality. I'd like to overview what we're going to cover today. First of all, I'd like to talk about the package's benefits to Mondelez. I'll overview the functionality very quickly. And I think it might be useful if I cover the 2012 presentation that we made, because there's a lot in this package, and some of the key features we don't have time to demonstrate live today, so I'll just cover a couple of the key features from 2012. Then what I'll do is I'll introduce the case study for today's analysis, a live demo by David Rose on how the use of JMP has evolved in consumer test evaluation since 2012. The benefits, this tool halved the analysis time. If you were a statistician and skilled, it would be something like 4 days to 2. If you were less experienced, it would be 10 days to 5, but it all added up to be quite a sizable saving in man hours. The actual scripted application made the analysis itself simpler and less error prone. Is my mic all right? And because it was simpler and less error prone, we were able to increase the number of people who were able to do the analysis. And as a result of that, it freed up the statistician's time to do more of the assessment of new techniques and build that new functionality into the tool and spend more time on doing what we should be doing rather than just running standard, more routine analyses. And another benefit as well is if we harmonise onto one system, which we've done globally, it makes the training efficiencies so much easier because everybody's learning the use of the same tool, and how we communicate the end result is consistent across all the business units. So we save a lot of time there, and the understanding has gone up considerably. I won't talk much about this page. All I'm doing here is showing you that the MCT sits in the main menu in JMP as an add-in. That's probably enough for that page. Underneath that MCT is a sub-menu, 4 main parts. Data manipulation. It covers areas of file manipulation, calculation of averages for further analysis. But one of the key features is the profile editor. This is a functionality that I really like about this tool. We can generate any number of product color portfolios in order that later on, when we do graphical representation of the results, we can switch between the profiles. And it's a way of illustrating some of the key interpretations that we want to do, changing colors to illustrate certain insights that we want to show. And the other part is raw data analysis, a series of charting tools here which perform on the individual consumer level. So it's a consumer test, 300, we're doing analysis by individual consumers under raw data analysis. And there's the summary data analysis section, which is actually working on charting the average data. So that's by just showing the product averages. And then the last bit is the customized report generator, which is something new. David will show and illustrate something about that later. A lovely page. I've not seen a page like this in all the time I've been here so far. Don't worry about it too much. I'm only going to say that the way the actual tool works, all the graphics have to be editable. This is the way in which the application works. There is an illustration of the control panel on the left-hand side, which is a list of editing utilities for the graphics for that particular application. So multiple comparisons by subgroup will give us these editing facilities for the graphics. Not all the editing facilities are needed for all the scripts that we run. So there is a grid that just illustrates very simply all the possible options to edit, and then going across in the columns, they're the applications that we run. And you can see that where the X's are, that says the functionality is available. So by the time you've run 2 or 3 of these applications, you get to know and you find your way around the control panel, makes all the others easy to use. There's a lot of commonality in the functionality within the editing. This was the presentation. It's only one page. I think you must have showed about 20 or 30 last year, but this is all in one page, so very much an overview. The case study that we looked at was to how we were going to find a line extension for a chocolate tablet. We wanted points of difference through technology and also ingredient. And we used the design of experiments approach. So the current product that we had was a firm center fill, a single piece, 2x6 tablet shape, and a single coating. The points of difference that we used to identify the line extension were fluffy instead of firm center fill, a finger piece instead of a single piece, 3x5 format instead of 2x6, and a double coating rather than single. We ran a consumer test and 150 or so consumers, and the 12 products that we identified through the experimental design were seen by all the consumers. So we got a score for each product by the consumer. The overall averages for the product scores for all test persons are listed in the table on the left-hand side at the bottom. We use a sort of a rainbow pattern to show the scores, the most liked products at the top and the least liked at the bottom. The bars connect products that score statistical parity. To actually illustrate the colour profile feature that I mentioned on the previous slide, here we're representing the centre fill level of firm and fluffy in the graphic that's just above the main chart. And here the level for firm is the blue and the yellow is the fluffy, and I don't think it takes a lot to interpret what that's telling us. The iterative clustering technique was something new to what we demonstrated in 2012. Mondelez became concerned about the instability of clustering solutions through the omission of a few consumers. So what we did, we invented a little procedure which utilised that, omitted consumers in a very structured way, and through iteration we worked out a consensus solution. The little grid that's yellow and red there actually shows the consumer assignments, the clusters. The consumers go across, the iterations go down, so when they get the same colour they're being assigned to the same cluster. The white ones are when they are omitted. And by working out the consensus, we get what we think is a more stable solution. And then what happens is we obviously then generate the mean scores for each of the clusters. What happened was that the current product was best liked in the largest cluster, 59%. And in the second cluster of 41%, the current product was least liked, in fact, inferior to all other products. In that 41% cluster, 815 product was most liked. The 815 product had all 4 points of difference versus current. That was introduced as a line extension with little concern about cannibalization of the current product. Now I'm going to go on to just to describe briefly the purpose of the case study, what the business objective was that we're going to analyse today is to execute a consumer test to identify a product design that satisfies both regional and within country consumer acceptance, and to weight that result by both volume and margin of the product per country. So the design itself is a sort of a typical design we run. It's a hall test, we call it a central location test. We run it in 3 countries, 100 consumers per country. They evaluated the 6 products, and what we're looking for is for the consumers to rate each product on a series of liking questions, including overall, on a 1 to 9 scale, where 1 is dislike extremely and 9 is like extremely, and also rate a series of what we call JAR attribute intensity ratings. That's just about right as a middle score. And it typically gives an idea of whether something is under-delivering or over-delivering on an attribute intensity. So 1 is when it's under-delivering, it's much too little. 3 is when it's just right. And 5 is when it's over-delivering, much too much. So before I hand over to David, I thought I'd summarise what he's going to show you. The 3 analysis techniques that we're going to show you that we're using more today and since 2012. 1 is something we call candidate selection, and Bradley Jones helped us out a little bit with this, so thanks to Bradley. I don't think he's here. Essentially what you're trying to do is to pick a subset of products from a larger set and make sure you've got good representativity of space. In our case, we're talking about sensory space. What this gives us is, instead of the politics and the judgmental favourites going in and all that sort of thing, we're getting a technical, repeatable solution, which means that anybody can generate it. Less choices, favourites, more of a technical approach. So, good thing. The next thing is we're going to talk about consumer attribute drivers of liking, a way of summarising that data. If anybody knows about penalty analysis, the output from penalty analysis, which is the analysis of JAR scales, is quite intense and a lot of it. And the reason is because you get a chart typically for every attribute for every product. So it does go into almost like the hundreds, and it's very difficult to assess. So what we did was we invented 2 new metrics. The penalty impact, which is the drop in liking when a product is scored and when it's not scored just right. So that score is an aggregate, a mean drop for across all samples, all consumers. And so it actually is in the context of the total product set. Then there's the penalty balance as a metric, and this is an estimate of the opportunity of a product attribute to improve its liking. So the adjustment here is looking at one side of the distribution when it's much too little and the other one is much too much. We use the frequency and the mean drop, and we take the difference between the 2. If that number is around 0, so it's sort of equally weighted both sides, then it says there's little opportunity to adjust it. If the number is high, it gives you an indication that some adjustment to that intensity could be made. By actually producing those 2 metrics and putting them into a table, David will show you that you can do a lot of interpretation just from that one table without looking at all the individual graphics. Hence, it facilitates discussions amongst the stakeholders, and we've had a very positive feedback from them on this particular chart or table. Then David will demonstrate the customised report generator. This was introduced fairly recently. We had one site that was holding up the complete global deployment of this tool to the RD&Q sites because they wanted to stick to fixed text formats. David did his usual skillful job of replicating the report formats that they generated, and then we went the extra mile and said, that's the default, but if you change these things, you can have any format you like. So with that, I'd like to hand over to David.
Thank you. Thanks, Jeff. I'm David Rose. I work in SAS UK, formerly of professional services, now of pre-sales, but what I'm doing hasn't really changed all that much, and I'm still enjoying myself absolutely as much as I was previously. What I'm going to do here then is to go through 3 little tasks, as Jeff has described on the slide before last. First of those tasks was to select 6 products from a set of 19 products. These are the 19 products in question. They consist of a number of variants with strange, funny names, with strange, funny interpretations. Doesn't matter about what those names are. Relevant point about this is that these products have all been tested, they've been assessed for their sensory characteristics internally at Mondelez by trained sensory panels, and the results of those assessments have been reduced to 3 principal components that you're looking at here, which have descriptions mainly covering flavour. 41% of all the variation in the data is explained as a characteristic of flavour. 32% firmness and 15% coarseness. If you add up all those figures, as I'm sure probably most of you have, you're getting close to about 90% or slightly more, which is a very, very good representation of all the variation that's present in that data. Now, what I need to do, however, is I've got to reduce those 19 products to 6 products to go into a consumer test. Why have I got to do that? Well, it's because consumer tests are pretty expensive things, but also consumers. Imagine somebody's called you off the street and you're doing your shopping on Saturday afternoon and they say, could you take part in a little consumer study? It won't take you long, 15 minutes of your time, and then we'll give you a special voucher or something. And you then try to get them to assess 19 products in sequence. It might just occur to you that they'd get a little bit bored by the time they'd done the 18th or 19th one. You have to make it feasible for them to do it. That's why we're doing this. We're reducing this to a representative set. Now, how are we going to do that? First of all, let's just take a look at these things. I'm going to produce a scatter plot, and I'm going to produce a scatter plot of those 3 principal components we were looking at a few minutes ago. There is my scatter plot. So each of those dots is a product. What you'll see is that they are liberally scattered around the space. What I've got to do is to find 6 products which represent that space as best I can. What I want to do is to find a good set of products which span the space as best I can do it. Now, that's not a difficult task. What I need to do is to say, let's go to the DOE platform. Sorry, I'm not using the MCTE tool for this one task. This is something we can do very easily within DOE, so that is what we're doing. What I'm going to do is simply to go to the covariate option here, and what I'm going to do is select those 3 characteristics as covariates. What I'm then going to do is say continue, but rather than having 19 runs here, I want 6 runs, and what I'm going to do is make a design based on just those 6 runs. Here is what came out. These are the 6 products that it's selected as being the best 6 out of the 19, just so we can see where they are. What I'm going to do is I'm going to colour those 6 points. And what I can see over here, this is where they are. So look for the red dots. What you may notice about the red dots is that, for the most part, they're scattered around the outside edge of the diagram. I'm only trying to estimate main effects here. I'm not interested in quadratics and curvature, anything of that sort. What I want is those dots to be as spaced out as they possibly can within this space, and to span the space as best it can. So there we are. That's great. Problem solved. Easy. I can go away home all happy. Not quite. Phone rings. Phone rings, and the Director of Research and Development says to me, David, I've got a problem. The problem that I've got is that the 6 products that you've selected for this consumer study do not include one particular product which I am particularly interested in. It is our reference product. This is our reference product, current MMI. You haven't selected it. I want that product included in the set. And I say, okay, fine. We'll add a 7th product and carry on regardless. He says, no good at all. The budget's already been agreed. You've got to do precisely 6. What you're going to have to do is throw away one of the ones you've got and replace it by this one here. Oh dear. Problem, how am I going to do that? Well, this has been traditionally a rather subjective task. Can we take this one out? Let's put that one out. No, that one's too similar to this one. Put this one in. No. We can do it rather more systematically than that, however. What I'm going to do is I am going to clear all those row states, and I am going to carry out another little analysis. But what I have here is a hidden column called reference. And if I unhide that column, what you'll see it contains is a whole string of zeros and a single 1. And that 1 is for my reference product up here. Now then, I've now got not a 3-dimensional problem, I've got a 4-dimensional problem. But I can still run this through the DOE platform. So if I now add as covariates flavor, firmness, coarseness, and reference, what it's now got to do is to find the best representative set of products in 4 dimensions rather than just 3. Now, again, if I just ask for 6 runs on all of this, what's it done? Well, it's now pulled in the product that I wanted to include. Why has it done that? Because all of these are zeros down here and there's a single 1. It has to cover all 4 dimensions. And since I've got a whole bundle of zeros here, the only way it can bring in that 4th dimension is going to be to bring in this product as well. Now, given that I've done that, let's just put those markers back again so I can see them. Also, let's just colour those markers. But then what I'm going to do is just colour this product here with a separate colour. Now what have I got? This is my reference product. So my reference product is now one of my 6, and it's redefined what the other 5 are going to be so that between them they still give me the best spread of the space I can get. It's not the absolute best, but it'll be pretty close. Great, we've now solved the problem. Now I can go home. No, I can't. There's another phone call. Another phone call, this time comes from the managing director, and he says to me, hang on a minute, David, you can't do this. Our new up-and-coming wonder competitor of all of our great products here, variant 11, has got to be included in this study. Why haven't you included it? I want it pulled in. We've now got 2 products that I've got to force into this thing. It's not a problem. I can do the same thing all over again. What I do, let's just clear all those row states one more time. Unhide my final column, which I hid earlier just to make sure I didn't have to type it in when the time came. In this instance, I've done exactly the same thing again. I've put a 1 on my variant 11 here. I've still got my reference, and I can go through the process exactly the same as I did before. Add factors, covariates, flavour, coarseness, firmness, reference, and competitor. Continue, and still ask for 6 products. Lo and behold, now what I've got is the 2 products that I forced into this, and the best 3 that I can, the best 4 that I can find, which will fill in the gaps. Here they are. Again, one more time, I'll just colour these. We got markers on those? Yes, I think we have. Let's add some colours to them. Reds. I want this one blue. And I want that variant 11 as a green. So that's what I'm going to do there. And here is my final design with 2 products that have been forced into it and the remaining 4 selected to give me the best overall spread of the space. Great, I've solved that problem. Now, that means I can now go away and do my consumer study. Let's take a look at the results of that consumer study, which I'm going to assume I have now carried out. The first thing I'm going to have to do, though, is close down a few of these windows, otherwise I'm going to get confused. What does my data look like? Here is my data set. This is what will come back from the consumer study. I've got 6 products. They've got all names here. They've all got code numbers, so people don't know what they are. The respondents are all identified by numbers. I've got 3 countries, which are called AAA, BBB, and CCC, because we don't want to tell you what they are. We have a number of rating scales: overall liking, appearance liking, colour liking, taste liking. And we have these things that Jeff referred to a few minutes ago called jar scales: colour jar, taste jar, aroma jar. What does that mean? These are 5-point scales in which colour is scored on a 5-point scale in which the respondent has been asked, is the colour too light, much too light, slightly too light, just about right, bit too dark, far too dark. Taste, too bland, slightly too bland, just about right. Too, what's the opposite of bland? I did have a word in my head. Strong, a little bit too strong and far too strong, and so on and so on. Now, why have I split the data up in this way? It's because they have different purposes. The liking scales are simply telling me exactly what they say. How much are these products liked with respect to these characteristics? First one, most important one. How much did you like it overall? The jar scales, on the other hand, are giving me a different type of information. They're telling me in what sense the product is either as good as it can be or not quite as good as it can be. I can use those jar scales to help me decide how to modify the product to make it better. And I can't do that from just these things here, because they don't give me any directional information. They just say it's nice or it's not nice or whatever it is. Okay. Let's take a look at an analysis of that data. I'm just going to bring up one simple little analysis here, multiple comparisons by subgroup. This is from the MCTE package. I am interested in looking at overall liking. That's all I want to see at the moment. And I want to group it by country. Reason I'm doing this is I want to be able to refer to these things a little bit later in the analysis. So I just want to put this on the screen to show you, to give a feel for what these products look like and how they compare with one another. Right, here we go then. So this is my overall analysis. 6 products here. I mention in passing that, first of all, this colour scheme has been deliberately put here to remind us, overall, which are the best products, which are the worst products. Green is the best product of the lot, orange is the worst product of the lot, and actually these last 3 here, P1, P2 and P3, are all pretty much on a par. 6.73, 6.76, these are decimal places. But that's not quite the whole story, because I asked for a split by country a few seconds ago, and I can call that up here. Here is my split by country. Sorry about the flickering on the screen. I really must make those tables invisible, but I will do it one of these days. Just haven't done it yet. Here are my 3 sets of charts. So this is country AAA, country BBB, country CCC. What do we get? Well, they're not all that different, really. We've still got greens at the top of the list for 2 of them. P5 is at the top of the list, P5 top of the list, P5 second on the list here. But the other one is still a fairly green one. We've got a shuffle of oranges and yellows beneath those. That's just to set the scene for how these products compare. Remember that P5 is the best one, Ps 1, 2 and 3 are pretty much on a par at the lower end of the scale, and that overall P1 is the least liked of the 6 products. Now, what I want to do with that is to try to relate the jar scales which I've got to the overall acceptance score, which we've just been looking at a few seconds ago. I'm not going to spend too long on this one because, as Jeff said a few minutes ago, jar scale analysis involves an awful lot of rather intricate work, and I'll show you just how intricate that can be. Let's just call up this data for a minute. Here are all my rating scales. I'm only interested in overall liking at this point, but I want to compare it with all of those jar scales. How many have I got? 7, or is it 8? I can't. Yes, it's 8. colour jar through after ace jar. Okay, there we go. And what I get coming out of that looks rather like this. In fact, it looked exactly like this. What I have is a number of charts. I've only got a tiny fraction of all the charts here that I could produce. What I want to do is just take you through one of them for a few minutes to sort of illustrate what it is we're getting out of this. First of all, I've only picked the first jar variable here, colour jar. I can pick any of the others or any combination of them, but at the moment I just want to look at colour. And I want to look at colour in respect of just this one product here, P3. This is comparing it with overall liking. Everything you're seeing here is overall liking. Now, how do I read this little graphic? Well, what I've got here is that 84% of my respondents thought that the product, this P3 product, was just about right for colour. That's pretty good. In fact, it's amazingly good. Only a very small number of people, 7%, thought that it was too dark, 8% thought it was too light. Don't get confused about the heights of those bars. You'll look at this and you say, hang on a minute, that's not 84% and that's 7%. No. What the bars are showing is the heights of those bars are telling me what the overall liking score is for each of those three categories. So the overall liking score for the people who thought colour was just about right is about 7. The overall liking score for the people who thought the colour was too dark is 0.97 lower than whatever this is. I haven't bothered to write in what the actual number is because all I'm interested in is the drop. Likewise, at the lower end of the scale, these people thought the product was too light. Now, what do I get out of that? Well, in terms of the possibility of making a change to this product, I don't have much scope for making a change because I've got the same number of people who think it's too dark as the people who think that it's too light. And also, supposing I were to make it darker, I would make these people happier and I would alienate this lot. There's no obvious direction in all of this. And what's coming out of that, therefore, is that the balance, one of the two statistics that I'm interested in, is virtually zero. The other thing that I get out of this is that the drop from here to either of these bars is actually very small. It doesn't go down much. The people who thought that the product was just about right for colour only scored it less than 1 point, on average, higher than the people who thought it was too dark for colour or too light for colour. So what that's really telling me is not only that there's no scope for changing it, but also that colour isn't really all that important. It doesn't matter. Compare that with the corresponding chart that you would get for taste jar. Redraw those charts now. Here's the other one. It's in the same position as it was before, but we've now got a very different picture. Only 60% of the people thought that the product was just about right for taste. A full 26% thought it was too strong, and 14% thought it was too weak. Now that is giving me a direction. Also, the drop is far higher. It's gone down by more than 2 points on this side and about 1.6 on this side. So the implication here is that this product is over-delivering in terms of strength of taste. There are a large number of people here, about a quarter of them, who think that it's too strong. So I have a direction. There's something I can do about this now. I can make it less strong for taste, and I can see from this that taste is fairly important. But I haven't looked at any of these other charts at all. I haven't, for example, considered aroma. In fact, I'm going to do something very, very silly. I'm going to check absolutely everything. I can't change the maximum number of products here because when I click this button, one of two things is going to happen. Either I'm going to get page after page after page of graphics, or something will go wrong and it'll throw an error. I don't think that'll happen. I think what it'll do, oh, look at that. What a mess. And that is only looking at one of my liking scores. It completely ignores the fact that I could have plotted this in a different way. We have a thing called a penalty bubble chart, which does clever things with the same information but displays it different ways. Tables, biplots, goodness knows what, goodness knows what. We thought we were being so clever at the time by producing all this, but actually we don't need it. All we really need is another analysis which summarises what we're actually interested in, jar scale tabulations. Same data, essentially the same analysis. But what I've now got, let's just pull those jar scales in there. Also, I'm going to want to split it by country as well in a few seconds' time, so I'm going to ask it for that. Let's do that. This tells me everything that I actually need to know. It summarises for me the penalty impacts. It summarises, whoops-a-daisy, wait a minute. Why am I'm a bit confused about something. Let me just go on describing it for a minute and then I'll sort out my problem in just a moment. What it summarises for me is the overall penalty impacts. What it also gives me is it summarises all the balances in this little table here. What surprised me was that these things weren't in descending order of jar scale, beg your pardon, of penalty impacts. I know that taste jar is the most impactful of the lot. So this should be at the top of the list, and colour jar here should be at the bottom of the list because it has least impact. Why it hasn't sorted that, I've no idea, but I'm going to sort it out afterwards. Don't mind about that. It doesn't matter, though, because what we're looking at here is a summary of how the balances compared for each of these various impacts. I know that taste is the most important characteristic, and what I've got summarised here is the balances for each of my 6 products. So, what I've immediately got is that these 2 products, P2 and P3, need their taste reduced because the balance is positive, it's to the right. I can also see that almost all of them need their texture reduced. It's too thick, it's too stodgy, it's got too much consistency. It needs to be made a lighter product. The fact that the consistency and the texture are saying pretty much the same thing doesn't surprise me, really. Also, you would find that the taste and the aftertaste will say pretty much the same thing. If it's got too strong a taste, when you've finished eating it and swallowing it, it's still in your mouth and it's still too strong. Okay, so what I have here is effectively a set of recommendations as to what I can do with all 6 of my products. I asked for a split by country a few seconds ago. I've got exactly the same tables for country AAA, for country BBB, and for country CCC. And what you will have seen when I flicked through those is that the pictures are actually quite different for some of these countries. So it's all very well producing a set of recommendations across all the products, but you might want to ask yourself, hang on a minute, if I were to implement these recommendations as to making products more strengthful taste, I want to give it less aroma, I want to make it less stodgy, whatever it is, am I going to alienate people in country A, or am I going to make people in country B happier, and so forth? These are business decisions. You'd be saying to yourself, well, hang on a minute, do I sell the same product in these various countries, or had I better sell different products in different countries because I can't satisfy everybody? Like I said, business decisions. But one point is relevant, which is that as things stand at the moment, I've calculated this thing across all products by assuming that these 3 countries are equally important. It may be that these countries aren't equally important. Suppose this is Azerbaijan, this is the Upper Volta, and this is the United States, which has a market 20 times the size of the other 2 combined. I need the possibility to change the weights in calculating this across all products calculation here, which is the reason that we did it. And what we have here is a little box which enables us to do precisely that. Suppose A has only got 10% of the market, B has 15% of the market, and C has whatever the rest is, say 75%. It doesn't matter if those 3 things don't add up to 100, because what I'm going to calculate here is just the relative proportions of those. So if I recalculate with the above weights, this is what I get, and what's evidently happened here is, ha-ha, I know what it is, I know what it is, I know what it is. I loaded jump 10, didn't I? That's what I did. I loaded jump 10, and sorting by column hasn't been implemented in jump 10. I should have been running jump 11. That was the reason I got confused earlier. Sorry about that, but you can see what I was trying to do. Okay, yes, 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 I know. Let's, go on, go away, go away, go away. How do I kill this off? Set the taskbar, shut it down, end task. Yes, please. Thank you very much. Silly me. What I should have been running was this one up here. Not to worry. We carry on. But I think actually in that I demonstrated almost everything that I wanted to be able to show on that. So what I'm going to do is I'm going on to go on now to the final part of this little demonstration, which is this business about the report writer. After I've done that analysis, I want to be able to report it in a convenient and easy format. But one of the requirements of all of this was that people had to be able to edit the report. What we have to be able to do is to export it in a format that people can say, well, I want to be able to copy it into Excel, I want to add a summary to it, I want to add a conclusion, I want to modify the titles, and so on and so on. So let me show you what we did about that. Customized report generator, interactive report builder. Same data set as before. I've already told it what these various things are here, rating scales, jar scales. So I'm only interested in the overall liking score because that was the one I analysed a few seconds ago, so I only want that one there. Jar scales, on the other hand, I was analysing all of those jar scales. So actually I'm going to pull them all in. There we go. Which product do I want to report? Well, again, actually I want to report all of them. And also, I may want to split this by country. No, I'm going to produce an overall report for the time being, rather than try to split into country, because that'll turn it into rather a long report. Point about this is that different types of scales are going to need different types of statistics reported for them. So what I've done over here is to define a default set of statistics for whichever type of scale I'm recording. If I'm looking at the overall liking score, what I'm going to want to see are the mean scores. I'm going to want to see a pairwise letter comparison report. I want to see which ones are different from which other ones. And that's it. I don't want to see more than that. There are other statistics I could calculate, but I probably won't want them. On the other hand, all of these jar scales are to be reported a completely different way. What I really want to see here is how many were below par, how many were just about right, and how many were above par. So by default, I've got that one ticked. I can change these. I can add various statistics most of the time. Some of the time I can't. Some of these boxes are completely greyed out because they're totally inaccessible. What is a kata scale? What is a kata scale? I didn't have any kata scales in this study, but what it is choose all that apply. It's simply a checkbox. It's saying, did you like this product? Yes or no. Was this product too big? Yes or no. It's a binary scale, so it doesn't make any sense to start calculating mean scores, letters, or anything like that. What it does make sense is to report what I've got here described as top box percent and bottom box percent. In other words, how many ones, how many zeros. That's all I want to see. Okay, so that's made creating a report in the format that I want remarkably easy. I'm going to generate that report. Sorry about the flickering. I'll deal with that in due course. There are two styles in which I might want to display that report. This is one of them. Here we are, the overall likings. I wanted the mean scores. I wanted the corresponding letters comparisons. If I've got the same letter under two of the means, it means those two means are not significantly different at the 95% level of confidence or whatever it is. Now, or I might want it in a different format completely. This one. Again, same summary statistics, but now presented vertically as opposed to presented horizontally. And finally, how am I going to export this stuff? We looked at all the exporting options available to us, and the two that really emerged were a PDF file and what I've described here is an XML Word file. We looked at the exporting for MS Word, and it needed something to be desired. It wasn't quite exactly what we wanted. We were seeing little text boxes. Sometimes the placements weren't where we wanted them to be. But if we were able to export this as an XML file, then we'd be able to import it into Word. What a shame that I can't write XML. But wait. It's not a problem. I don't need to be able to write XML to do this. If I were to create a report in exactly the format that I wanted in MS Word, export that report with dummy data as an XML file, read it into JSL as text, substitute the real data for the fake data, and re-export it, what I would get would be in Word exactly what I want. So to do that, all I've got to do is let's ask for a report. I want it prefixed with today's date. If I save it in that format now, that report has now been written as an XML document, and I can open that in Word. And here it is. And we thought we were being so clever with that until we saw Dr. Saul's presentation this morning, and we thought, oh, why did we bother? But we have exactly what we want, and we've got it exactly the way we want it right now. Thank you. That's the end of my presentation.
So I'm sure Jeff and David between them will be happy to answer any questions. You can use the microphones in front of you if you have any, please.
Any questions, please?
So my question is, you have like 19 different brands there, right? You only have allowed to use 6 of them. So is it possible, because sometimes you could have multiple option designs there, so maybe the first time you didn't get your current product selected, the second time you run maybe like 2 option design, you could select 6 brands which include your current product.
Well, our design is being selected from the result of the principal components analysis that have been run on it. So we're constrained in terms of which products are sort of positioned in the experimental design space before we've even begun. We're sort of past the point where we're saying we're trying to design an experiment where the flavour is scoring either 40 or 80. I mean, we can't control what the sensory panel is going to make of any particular sensory attribute. We can't design that. All we can do is to work with the results of the principal components analysis that we have, which is the reason we're working that way. Hello.
In terms of time saved, so you have a customized report writer and you have these kind of customized analytics. Can you give me an idea? You're saving a lot of time for your analysts. Can you give me an idea of which saves the most of your analyst time and which saves the least? And yeah.
The assessment of 50% was purely my saved time, and at the time I did it, it was probably about Jump Summit presentation 2010. So it was the initial, the first time we used the software. Now with the increased complexity of the jar scale evaluations and all that we do, I would imagine we've saved even more time. But the estimate comes from me personally halving my time, and I took myself to be the expert analyst at that time and assumed that, you know, that could be a stated amount of 50%. Which part? The data, we heard earlier today that the data treatment, the preparation, you don't save hardly any time there. But when you get it into a format you can process, that's where all the time is saved. The versus what I used to do before, right or wrong, I used to generate charts in Excel, and then I had to change the colours of all the bars that we were presenting in the range test, because Excel does it in order of score, and if you get order, it would switch the colours on the products. So what saved the most time? It would be the assignment of colours to the rows, or the products. And that saves probably the most time, and is a key feature of this particular application. Hi.
Thank you for sharing. I was wondering, do you actually run drivers analysis to understand what are the key attributes that drive preference across your products and those of the competition? And then wouldn't that be easier for you to find out which attributes your products lack versus the competition, so you can actually go and develop products that are more targeting to those elements that you kind of could leverage? I mean, somebody has done the work for you, meaning there's an acceptance test already done.
Yeah, the scope of what we covered today was consumer responses to the products, and the test that we actually showed had a very limited number of, if you like, current products on the market. It had our current product, and everything else was a variant. I think David called one the competitor. That was just for convenience to introduce it as a second, forcing the second one in. But you can do other studies like category appraisal studies. You can get information on how to alter your product versus competitors, where they're performing on drivers, but it is on jar scale. We do other analysis using PLS and stuff like that to understand drivers of liking. But in the scope we covered today was just how we would evaluate the jar scales.
Thank you.
Okay, well, it looks like there are no further questions, so please join me again in thanking Jeff and David.